I'm very delighted with the fact that children have really got back to us with their queries and with their doubts, and they've really come ahead and told us what they really have as their doubts and their concerns, and we are committed to help them get to their doubts. I've passed on these questions to the teachers, and these teachers are going to write and solve so that these children can get these questions. There is something that I would like to tell every student listening to this. There is something that I want to tell. What you learn today, you will forget tomorrow. That doesn't mean you get diluted in your motivation and stop asking or get disheartened that ये तो पढ़ा था last week लेकिन भूल गया. It's a part of life that whatever you will learn, there's a high tendency of you forgetting it. But don't get demotivated. Keep posting in your doubts, and we are very committed to pass on your doubts to the teachers and to ensure that the teachers solve your doubts and you get back on track as soon as possible. The place that you're seeing is a place where I normally sit and work, and this is my place where I sit and work, and I'll just show you around a little bit of how my office is and how messy it is. To be very honest, so this is I'm gonna have the apple in some time. These are the worksheets that I work and the pending work. That's my laptop. And that's my favorite Iron Man skin on it. This is where we sip hot water with green tea sometimes. This is where I keep this is from where I picked up the Starbucks coffee. I picked it up and I use that as my pen stand. This is where I keep all the crap. My watch, I had lost my battery and just got it repaired. Wearing another one. I'm just learning to do this cube. This is what I was doing, and I kind of know this, not very well, but yeah, I'm gonna learn doing this. It keeps me occupied and my brain in place. That's some books from where I make notes for all you wonderful children. So yeah, good luck, do well. Go through the video now and tell us how that helped you, and also let us know whether you have some more doubts, and please write into us.
Equation of kinematics. Here we have the terminologies of u, v, a, s and s of n, where u is the initial velocity at time t is equal to 0 seconds. V is the final velocity of the particle, a is the acceleration of the particle, s is the distance travelled in t seconds, and sn is the distance travelled in the nth second. Now when the particle is moving with acceleration 0, we have v is equal to u. The final velocity is equal to the initial velocity since there is no acceleration, and the distance travelled will be equal to the initial velocity into the time taken to travel, as acceleration is 0. Also, points to remember is it will be a unidirectional motion. When we have the acceleration 0, and there will be one-dimensional motion if initial velocity and acceleration are parallel or anti-parallel to each other. Now when the particle moves with constant acceleration, we divide the formulas into two parts. One is the scalar part and one is the vector part. Now we know scalar does not consider the magnitude, whereas the vectors do. The formulas under scalar would be v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and s is equal to u plus v by 2 into t. S of n would be u plus a by 2 2n minus 1. And when we consider vectors with the magnitude, v bar is equal to u bar plus a bar t, s bar is equal to u bar t plus half a bar t square, v bar into v bar minus u bar into u bar is equal to 2 a bar s bar, s bar is equal to half u bar plus v bar t, and Sn bar is equal to u bar plus a bar by 2 into 2n minus 1. This was kinematics. A body A is thrown up vertically from the ground with a velocity v0 and another body B is simultaneously dropped from a height h. They meet at a height h by 2 if v0 is equal to, options are A root 2gh, B root gh, C root gh by 2 and D root 2g by h. What we do first is let's represent it diagrammatically. If we say this is the ground and this is height h, then we'll have to divide it by 2 as h by 2 and h by 2. So the body B is dropped from here and A was thrown up from here with V0. So now using the formula S is equal to ut plus half at square. For body A, u was equal to V0, A is equal to minus g since it's thrown upwards, and S is h by 2 since it has to meet B halfway. Therefore, h by 2 is equal to V0t minus half gt square. And for B, we have u is equal to 0, A is equal to plus g since it's being dropped, S is equal to h by 2. Therefore, we have h by 2 is equal to half gt square. Now, since we have h by 2 on both these terms, let's equalize them both. Therefore, we get V0t minus half gt square is equal to half gt square. Therefore, we get V0t is equal to gt square. Substituting the value of t in equation, we get h by 2 is equal to V0 into V0 by g minus half g V0 by g the whole square. This substitution happens here. This should be 1, this should be 2. So from here we get V0 square g minus half V0 square by g, which on solving further we get the LHS is equal to h by 2 is equal to 1 by 2 V0 square by g, or it could be written as V0 square is equal to gh. Therefore, V0 would be root gh, which is option B. A stone falls freely from rest from a height h and it travels a distance ah by 25 in the last second. The value of h is A 145, B 100, C 122.5, D 200 and E 175 meters. So we started. Let the stone fall. Let the height of the stone that falls is h in t seconds. So we would have u is equal to 0 and the acceleration would be g since it's falling. Then using dn is equal to u plus at to n minus 1, the formula, the distance traveled by the stone in the last second would be 9h by 25 as given equals to g by 2 2t minus 1 since a is g and n is t. Distance traveled by the stone in t seconds would be h, that can be given by the formula h is equal to half gt square since u is equal to 0. Now we divide the equation, this we say as 1 and we would call this equation as 2. Now divide 1 by 2, we get 9 by 25 is equal to 2t minus 1 by t square. If we solve this, we get 9t square is equal to 25 into 2t minus 1, which on solving we get 50t minus 25. Now you bring this to the LHS, we get 9t square minus 50t plus 25 is equal to 0. On solving this equation, we get either t is equal to 5 seconds or t is equal to 5 by 9 seconds. Substituting t is equal to 5 seconds in equation 2, we would get h is equal to 1 by 2 into g, that is 9.8, into 25, which is 5 square. We get 122.5 meters, which is option C. A particle moving in a straight line covers half the distance with a speed of 3 meters per second. The other half of the distance is covered in two equal time intervals with speed of 4.5 meters per second and 7.5 meters per second respectively. The average speed of the particle during this motion is option A 4.0 meters per second, B 5 meters per second, C 5.5 meters per second, and D 4.8 meters per second. So first what we do is if t and 2t2 are the time taken by the particle to cover the first and second half distances, t1 and 2 times t2 are the distances covered, then t1 would be equal to x by 2 by 3, which would be x by 6, and x1 would be 4.5 t2 as given, and x2 would be 7.5 t2. We get this from the information that is provided in the question. So what we do now is we add them both, x1 plus x2 is equal to x by 2. That gives us 4.5 t2 plus 7.5 t2. Therefore, T2 is equal to, we convert this equation, substitute it as x1 plus x2, we get T2 here is equal to, there's a T2 here as well, T2 is equal to x by 2 into 12. So, it would be x by 24. Now, the total time taken t is equal to t1 plus t2 as mentioned in the question, and substituting the values of t1 and t2, we get it as x by 6 plus x by 12, which gives us x by 4. So the average speed is equal to 4 meters per second, which is option A. The acceleration of a particle is increasing linearly with time t as bt. The particle starts from origin with an initial velocity v0. The distance traveled by the particle in time t will be option A v0t plus 1 by 3 bt square, option B v0t plus 1 by 3 bt cube, C v0t plus 1 by 6 bt cube, or D v0t plus half bt square. First what we do is write the formula, dv by dt is equal to bt. Therefore dv, that is change in velocity, would be bt into dt, which gives us v is equal to bt cube by 2 plus k1 on integration. At t is equal to 0, the initial velocity would be 0. Therefore, k1 is equal to v0, and we get v is equal to half bt square plus v0. And now again we have dx by dt is equal to half bt square plus v0. From this we get x is equal to half bt cube by 3 plus v0t plus k2 on integration with respect to t. Therefore at t is equal to 0, x is also 0, which means k2 also must be 0. Therefore from this we get x is equal to 1 by 6 bt cube plus v0 t, which is option C. A particle is moving with constant acceleration from A to B in a straight line AB. If u and v are the velocities at A and B respectively, then its velocity at the midpoint C will be A u square plus v square by 2u the whole square, b u plus v by 2, c v minus u by 2, or d root of u square plus v square by 2. Option E, v square minus u square by 2. So first what we do is we plot out on a diagram start point A, end point B and midpoint C. Here we know the speed would be u and here it would be v. Let's say the distance, the whole distance between AB is equal to s. Let s be the distance between AB and A be the constant acceleration of the particle. Therefore, we can write v square minus u square is equal to 2as. Or in another form, we could say as is equal to v square minus u square by 2. If vc is the velocity at midpoint C, then we could write this equation in the term vc square minus u square is equal to 2a and s by 2, since that's the distance to point C. Therefore, vc square is equal to u square plus 2a plus 2, this would be as, sorry, u square plus as, which would equal to u square plus v square minus u square by 2. From this term we get vc square is equal to u square plus v square minus u square by 2. Therefore, taking root on both sides, we get vc is equal to root of u square plus v square by 2, which is option D. An aircraft is flying at a height of 3,400 meters above the ground. If the angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees, then the speed of the aircraft is A 19.63 meters per second, B 1963 meters per second, C 108 meters per second, D 196.3 meters per second, or E 10.8 meters per second. What we do first is draw a diagram that represents point A and B and an observation point O, that is subtending the 30-degree angle, and the distance from A to O is 3,400 meters as given. Since O is the observation point at the ground and A and B are the positions of the aircraft for the angle AOB is 30 degrees, the time taken by aircraft from A to B is 10 seconds. Therefore, by using the formula tan 30, which is tan theta is equal to AB, that is opposite upon adjacent, we get AB by 3,400. Now we get AB as 3,400 tan 30, which is equal to 3,400 by root 3 meters. Therefore, the speed of aircraft can now be calculated as B is equal to AB by 10, since it takes 10 seconds from A to B. Now we know the value of AB as 3400 by root 3 into 10. Therefore, we get, on solving this, we get it as 196.3 meters per second, which is option D. A stone dropped from a building of height h and it reaches after t seconds on earth. From the same building, if two stones are thrown with the same velocity u and they reach the earth's surface after t1 and t2 seconds respectively, then a. T is equal to t1 minus t2, b. T is equal to t1 plus t2 by 2, c. T is equal to root of t1 t2, or d. T is equal to t1 square plus t2 square. So if a stone is dropped from height h, then we have h as half of gt square. If a stone is thrown upward with the velocity u, then we have h is equal to minus ut1 plus half gt1 square. If a stone is thrown downward with the velocity u, then h is equal to ut2 plus half gt2 square. From this we get minus t1 ut1 plus half gt1 square is equal to half gt square. Solving this equation, we get ut1 plus half gt square is equal to minus 1 by 2 gt square. Now dividing these two equations, we have minus ut1 by ut2 is equal to half, we have ut2 plus half gt square, gt2 square plus 1 by 2 gt square. Now dividing these two equations, we get minus ut1 by ut2 is equal to 1 by 2 gt square minus t1 square upon 1 by 2 g t square minus t2 square. By solving this equation, we could get t as root of t1 into t2, which is option C. A particle is dropped vertically from rest from a height. The time taken by it falls through successive distances of 1 meter each will then be A. All equal, being equal to root 2 by g seconds. B. In the ratio of square roots of the integers 1, 2, 3 and so on. C. In the ratio of differences in the square roots of the integers, that is root 1, root 2 minus root 1 and so on. D. In the ratio of the reciprocal of the square roots of the integers, that is 1 by root 1, 1 by root 2, 1 by root 3 and so on. So first what we do is, we know h is equal to ut plus half gt square, which is 1 meter height into 0 into t1 plus half g t1 square. From this we get t1 as root 2 by g. Velocity after traveling the distance of 1 meter would be v square is equal to u square plus 2gh. Therefore, from this we would get 0 square plus 2g into 1. Therefore, v is equal to again root 2g. Since v and u is equal, now we know v is equal to root 2g. V and u are not equal. For the second 1 meter distance, we know 1 is equal to now root 2g into t2 plus half gt square gt2 square. This gives us gt2 square plus 2 root 2g t2 the whole minus 2 is equal to 0. Solving this for t2, we get t2 is equal to minus 2 root 2g plus or minus root of 8g plus 8g the whole by 2g, giving us minus root 2 plus or minus 2 by root g. Taking positive signs, we get t2 is equal to 2 minus root 2 by root g. Now, since we've taken the positive sign, it is easier to take a ratio of t1 by t2, giving us root of 2 by g and 2 minus root 2 by g, which on solving we get 1 upon root 2 minus 1 and so on for the integers. Therefore, it is option C. A point initially at rest moves along x-axis. Its acceleration varies with the time as a 6 is equal to 6t plus 5 meters per second square. If it starts from origin, the distance covered in 2 seconds is option A 20 meters, B 18 meters, C 16 meters, D 25 meters. The given acceleration A is equal to 60 plus 5 from here. Now A is equal to dv by dt, as we know. Therefore, we get dv is equal to 60 plus 5 dt. Integrating it from 0 to v, dv, we get 0 to t 60 plus 5 dt. Solving this, we get v is equal to 3t square plus 5t plus c, where the c is constant of integration. Now when t is equal to 0, v is equal to 0 and c is equal to 0, we get v is equal to ds by dt, which is 3t square plus 5t. Integrating it with the conditions of motion, that is t changes from 0 to 2 seconds, s changes from 0 to s. Therefore, we have integration of 0 to s ds is equal to 0 to 2 3t square plus 5t dt. Now, if we solve this, we get s is equal to t cube plus 5 by 2 t square from 0 to 2. Applying the values of t from 0 to 2, we get 8 plus 10, that is 18 meters, which is option B. A parachutist, after bailing out, falls 50 meters without friction. When parachute opens, it decelerates at 2 meters per second square. He reaches the ground with a speed of 3 meters per second. At what height did he bail out? A 293 meters, B 111 meter, C 91 meters and D 182 meters. First, what we do is we represent it in 3 different stages. This is height h, where parachutist is at velocity v, and here he is at velocity 0. This distance is 50 meters, point A, point B, point C, which is the ground. Now we know v square is equal to u square plus 2as, which is equal to 0 plus 2 into 9.8 into 50, giving us 980 meters per second square. At point B, the parachute opens and it moves with a retardation of 2 meters per second square and reaches the ground point C with a velocity of 3 meters per second. For the part B to C, by applying the equation V square is equal to U square plus 2AS, we know V is equal to 3 meters per second, U is equal to root of 980 meters per second, and the acceleration would be a minus 2 meters per second square, and S would be equal to h. So we know 9 is equal to 980 plus 2 into minus 2 into h. Therefore h is equal to 980 minus 9 by 4, giving us 971 by 4, which is equal to 242.7 meters, which is roughly 243 meters. Therefore, adding 50 meters of the initial distance traveled and the h obtained, we get the total height as 50 plus 243 meters, which is 293 meters, which is option A.